This is a HVAC balance simulator I've built. It simulates residential and commercial HVAC systems with a fan, some ductwork, and dampers to regulate airflow. I have a manometer here to measure the pressure inside the ductwork. And the idea is to think about the system effect and the airflow. How did you get all these styrofoam balls to be basically the same height so that each tube will have the identical airflow? So when we start this up and the fan starts blowing air, what do you think is going to happen? Are all the balls going to go to the top? Are they going to float in the middle? Or will they be random? Okay. So I'll start it up. As you can see, this one's getting a little bit of air, just a little bit of movement. These three are getting most of the air, and this one's not far behind. But what happens is when the fan comes on and goes across, the pressure builds up and pushes this ball up, then the pressure builds up this way and then pushes this ball up and all the way across. At first, the air is just going by here so fast that it can't turn and get into this tube, and it's just going to the end. The manometer is reading 0.05 inches of water, so that's the pressure inside the ductwork. So now we're going to regulate the dampers right here to get all the balls to be equal in height. And you would assume that you would start with the highest one and work your way back to the lowest one. But actually, you want to take the lowest two and get them to be equal. Okay? And just to prove what the airflow is going through here right now, we're going to check the airflow using the pressures across each damper, and I'll record them on a piece of paper. And we have a formula that we can actually figure out what the CFM is. So Q is cubic feet per minute, or CFM. K is actually a multiplying factor. And on this particular damper, the damper handle has a series of numbers that whatever you set the handle to will become your K factor. And then the change in pressure, the delta P, is actually the difference from the high side to the low side of the damper, and you multiply it out. Okay? Alright, so now that we're getting ready to measure the airflows, I've got a data sheet that we're going to record what the airflows are currently right now. So the static pressure in the system in inches of water is at 0.05 inches of water. And each damper has a high port and a low port. And I have a meter that has a high port and a low port. And I have it set to inches of water. And I simply slide the tubes on and take a reading. This one is at 0.16. So I'll record the change in pressure at 0.16. And at the same time, I want to verify the damper's open and the setting is 850. So I'll record that as the K factor. And I'll do the next one. Its reading is 0.20. So I can record that as 0.20. The damper is still at 850, it's wide open. Number 3. .20 also. And it should be at 850. Number 4 is at 850. And the pressure reading is .20. And the last one, number 5, is .20 at 850. All right, now that we have all the changes in pressure and the cage factor, all we have to do is take the reading of the change in pressure of 0.16 square root times the K factor, in this case was 850, and it gives you the CFM. So on the very first one, we came up with 340. On the second one, 0.20 square root times 850 is 380, 380, 380, 380. So these 4 are in balance, but this one is not. So we got to adjust all these to make them all the same. All right, so now we have the total flow, we know the total static pressure. We're going to start adjusting. And we're going to start with this one, and we're going to bring it down until it equals the first one. And I want it to react the same way. They both look like they're doing the same. This one went up a little bit more, so there's a little more air going through there. And we're going to bring it down. And notice this one went up just a little bit. Let's fine tune this one. Now they're all kind of hovering about the same. All right, we get to the last 2. We're going to take this one down, and notice what's happening over here. All right, these 3 are okay. This one's still struggling a little bit, but we know it's already the lowest one, and it has a problem getting its air. So I'm going to leave these right here, right now, and we're going to adjust this one and see what happens. Notice that the first one's going up as I'm closing this damper, and it's not going down just yet. But at some point in time, alright, so now they're all hovering right there. They're not touching the top of the caps, they're just hovering fairly close together. And I let it run for a little bit just to make sure everything's going to be fine. So now, hopefully, the pressure in each one of these is identical or really close together. I come back to my manometer and I read that it's 0.09 now. So it went from 0.05 to 0.09. The pressure's building up. The fan's working a little harder to move that air. All right, so now that we have the balls all about the same height, we've recorded the 0.09 in our system. We're going to read the airflows again. Meter set on inches of water. And now I take that reading. It is 0.20 now. And the K factor on this one, since it wasn't moved, is still 850. And we move down to the next one. And the pressure has gone up to 0.24. But this time the K factor is now at 360. And we'll move to the next one. And the pressure is 0.28. And the K factor is 290. Number 4. Is at 0.32. And the K factor on this one is 280. And number 5, the pressure in inches of water is at 0.32, and its K factor is about 280 as well. All right, we've gone through the second run of dampering and the measurements, and these 4 are really close. This one is just a little shy, and it still needs to be tweaked a little bit more, so you'd actually go through the system one more time, and we would adjust the dampers just a little bit to bring this one up a little higher and to bring these down. And then we would go through, read it again, do the math, and record all the data, and this system would be in balance. With this system, we've done the pressure reading and done the math on this. I've also included an additional port where we can actually do a duct traverse, and using the tools to read this, the same meter and a pitot tube, we can actually take the airflows, run it through another calculation, actually a couple of different calculations, and we can verify how much air is actually passing this point compared to our readings of each of these, and they should be equal. The one thing about these dampers, the damper handles are every 50 reading, so you kind of guess in between the readings, and some of the errors might be just because of the damper reading may be wrong. So I have the meter back. I have it set on inches of water again, and I've hooked the pitot tube up to it, and you would stick it in there and point it toward the fan, and you would take multiple readings. You have to calculate where precisely the readings are across and where the readings would be in a vertical position. And then you take those measurements and run them through another formula to calculate the quantity or the CFM going through the ductwork. The dampers actually come with a chart, a flow chart, that gives you the pressure reading that you take across here, and the curved lines here are the numbers on the damper itself. So you take your reading of, let's say 0.8, and the damper handle at 350. You follow that across until it hits that curved line, and come across the bottom is quantity or your CFM, and you can get a measurement. So more precisely calculation, or you can come here and estimate again. Since you're guessing between numbers here, you're also guessing in between numbers here. So